Hi, my name's Noah Reef. Welcome to the Coding Dude channel. Last time in our first part to the Introduction to Python series, we just kind of discussed what the Python programming language was, and what it was useful for, and how to install it into our desktop or laptop. And we kind of wrote our first line of code, which was to print out hello world, which is usually considered a good way to just make sure that your entire setup is working, and just kind of like a coding standard of good luck. It's like a good omen to just run it and to have your uh, freshly working IDE print out hello world. Uh, so kind of not getting too much into the weeds of what print did, or if you couldn't kind of already tell what was happening. Um, Print is a function in Python, which we will get more into later, that will print out whatever's between uh, these parentheses, and usually whatever you're going to print out will be between these quotation marks. But we're going to cover more about what's with these quotation marks and more of the basics of Python in this video. So a few things to kind of note within any programming language, and we're going to kind of focus here in Python, is that there's some what are called data types. And data types are really just data or information that you are going to use within your code. So there are things that are like called integers or ints. Um, this is usually how you would write it in any other sort of uh, programming language. But an int, really, all that is, mind you, is like some number like 7 or 8. But it wouldn't be something like 2.5 or 2.45. These are this right here, this is not an integer. An integer is a whole number, if you might remember from your math class. Uh, but things like 2.5 are what are called floats slash doubles. Um, and so that would be your 2.5, 1.3, things with decimals in between. The interesting thing to note, though, is a double and a float in a programming language is also can be considered like 2.0. So whole numbers or integers in programming languages are really just the numbers themselves, the whole numbers, these integers. But a float and a double has these decimal values, but anything that's also represented as 2.0. So you would think like 2.0 and 2 are equivalent, but they are actually two different data types, at least to Python, as being two different things. And we'll explore more about how that can be dealt with later. The one that we kind of dealt with earlier when we were printing hello world is called a string. And a string is really just a word. And we usually like to think of a string as a collection of characters, which we'll get into next after string. But a string really is just a word. So like usually whenever we want to refer to something as being a string in Python, we'll put it between quotation marks. So for example, hello world is either it's a word or a sentence that we might. So hello world would be a string, but so would hello, so would world. These are all examples of strings. They're just words or collections of words, and they're usually held between these double quotation marks here. So kind of now getting into what I was referring to before, there's a character, or we usually call it a char in programming, and basically they're the individual characters. Now, usually it's usually traditional to use just single quotes, but you could also do it in double quotes. It's just fine. But usually when you're referring to a character, it's like just the letter C. And this is the same thing for things like, something like the capital letter C or A. It doesn't, it's the individual characters. So kind of going back to what I said earlier about strings, is we usually also can think of strings as collections of characters, right? So like this string right here, hello, is really just a collection of individual characters, the individual character H, then the individual character E, and then L, and then L, and then O. And all of those characters are put together to make this single string, which is the word hello. I hope this isn't too confusing. Just kind of as a recap, just to kind of get us back to where we are. This is a lot to kind of throw out at first. An integer is just a whole number, like the number 7, 8, no decimal. A float or a double is a decimal value, which can be 2.5, 1.3, and even something like 2.0. A string is just a word or a collection of words. So things like hello world, or the individual word hello, or the individual word world are examples of strings. And a character is like an individual letter. So like the letter C or the capital letter A. And so we those are some of the very basic data types. There is one more though to kind of cover right now as part of the basic data types, which is what's called a Boolean. And the rest of these, you have a general idea of what they are. You've worked with probably numbers before from basic math, and you've probably worked with letters and words from your English class or whatnot. But what is a Boolean? So it comes from Boolean mathematics, which have to deal with true or false statements. And so a Boolean value can only be of one of two states. It can either be true or it can be false. And it kind of has to deal with logic more than anything else. And not logic in the sense of, is it rational, like smartness? I don't know, whatever you think of logic conventionally. It just has to deal with certain statements having an either true or false value. So sort of an example might be, my name is Noah, right? Would be considered a true statement because my name is indeed Noah. But if I said my name was Dave, well, that'd be false because my name isn't Dave. So it's just sort of your general true or false. We'll explore more about what we can do with these Boolean values, but just note that a Boolean value can really be either only true or false, and that's it. So this is sort of the basic data types that you want to kind of keep track of in Python, and these are sort of true for many different programming languages as well. So not only in Python, but in C++, JavaScript, you will have data types just like these to kind of keep track of. So kind of revisiting our good old friend, the print function, what we were really doing is we were putting a string of, so like I'll change it, my name is Noah, is really just a string that we are putting together, and the print statement will actually go ahead and it will print the statement in between the parentheses out to the console window. So when I run it, as you can see, it will go ahead and print my name. We kind of want to discuss here with Python is the idea of a variable. And a variable really is just a container that stores data types, stores information and data. So a prime example might be, suppose I wanted a variable called name, and we're going to set it equal to the string Noah. So all this is really doing, just to kind of get, is that we've declared a variable, some sort of container that's called name, and it's going to hold inside of it this string that is my name, Noah, and you can put your name or whatnot if you're following along. And to kind of prove that Python has actually stored that string into it, is if I go ahead and I do print name, what should happen is it's going to go ahead and print out my name. And so this is sort of to just prove that the variable name is storing this string. Now, it could be whatever, like it doesn't have to be my name. It could have been just the number 8. And to sort of also clarify something. Python has a tendency to, when a single, like when a variable or an integer is passed in by itself into this print function, it tends to print it as a string, covering something down the line known as concatenation. We couldn't just do something like this, and I'll explain why when we get to it. But right now, just kind of sticking with variables, as you can see, this variable name is holding on to whatever information I put into it. So if I put like the Boolean value true and run it, it prints out that true. If I put in 2.3, sorry, and I run it, it prints out 2.3. So you can see that this variable name is holding on to whatever information I put in it. Now, good convention would be that whatever you make the name of your variable, it should be related to what the information you're putting into it is. So obviously, it would be probably a really bad idea to put the number 8 for name, because unless the name of the thing is 8, then you probably don't want to do that. But here, this would probably be good convention because my name is Noah, and I'm storing into the variable name my name. So it's usually good. We could be more explicit with this and say my name. And this is also usually a good convention in Python and also in JavaScript, which is called camel case, which is you want to start the name of any of your variables lowercase. And if you are combining like words like my name, the next word should start capitalized. So, for example, maybe if I wanted to say my very cool name would be an example of camel case. The M in my, the very first word in the variable name, will start off lowercase, and then every new word, very cool and name, will start with a capitalized letter and then back to lowercase. And that's called camel case, and is usually a good convention to follow. It's also a good convention to follow that you don't put any, Python won't let you use any sort of like things like dashes or hash, like you can't use any sort of symbols. It's also usually a bad convention to use numbers. You can, but it's just usually frowned upon. So this is usually a good convention that you go ahead and use camel case for your variable names, and that your variable name is somewhat associated with what information you're going to store. And Python doesn't only have you can do a lot more than storing information like that, storing like strings or integers or floats or whatnot into a variable. You can also do something like maybe favorite num. Maybe I'll say my favorite number is 7. And maybe what I want to do is I want to add 2 to my favorite number. So one way we can do, I guess for lack of better words, operations with variables and do things with other variables. So I guess before we continue, to kind of show you what I mean, is that I can go ahead and remember inside of the favorite num variable, the number 7 is in it. And so when I use this variable result, I'm going to add 2 to my favorite number. So here, mentally, if you can with your imagination, pretend that really this can be substituted with this 7. And so maybe here to kind of show you what should happen is when I print out result, I should get 9. So when I run it, you can see that I get 9. And so suppose maybe my favorite number changed and I really like the number 10. Well, now here in my program, the favorite num variable can now be substituted with the 10 that I've now changed what it's storing in this variable. So if I run my program again, you can see now I have 12. Now, obviously, you could just, instead of adding 2, you can also set variables equal to the value of other variables. So for example, here, result is equal to favorite num, and right now we can see that my favorite num is 10. So when I go ahead and run the program, you can see that it's 10. Now, the thing to kind of be wary of when it comes to dealing with variables is when you instantiate them with the information that they're supposed to hold is really important. So let me kind of give you an example. So here, I kind of want to have you guess, give you maybe just a little bit of time to maybe guess what will happen when I go ahead and print result. So if you maybe you might guess that result might be either 10 or it might be 5. So if we go ahead and run it, it's still 10. And that's because the time that I call when I instantiate result with the information of favorite num at that moment is 10. So really, result is really just storing into itself 10. So even though I change favorite num down the line, result is still holding on to that 10. I never change result to be that different thing, to be 5 when I change it. So, but if I do it again, and I say, make result my favorite num, well, now if I run it, now it's 5. So it's important to remember when you end up setting a variable equal to something to like another variable, you need to know when the importance of when you change the information of certain variables, right? So since I don't change the value of favorite num till later, result is really just storing that 10. And maybe another way to think about it is really all result is really saving is whatever is currently in favorite num and isn't really keeping track of favorite num as a whole, but is really keeping track of whatever was in it when you set it equal to that. So at the time that I call result here and I set it equal to favorite num, I'm really actually just setting result equal to 10 because that's what's in favorite. And not really keeping track of favorite num itself so that when I change it later, result will print it out. Obviously though, if I go ahead and set result equal to 2, it doesn't matter what I do for it, result is just going to be equal to 2. So the best way to kind of think about it in sort of sequentially is that your program kind of executes line by line. And so it's sort of it's like an order of events here, right? Is to kind of keep track of what happens first, then what happens second, what happens third, and just trying to like keep track of where the state, if you will, of everything as you're kind of running through your code. So this is sort of the basic idea of variables and kind of working with data. Now, I kind of alluded to it earlier, and I apologize that I kind of skimmed over it, but is that you can do operations in Python. So here for the add variable, I'll show you. You can do 2 plus 3. So you can do normal addition. You can do subtraction. So I can do like 5 minus 2. You can do multiplication. So you can do like 3 times 2. You can division, so you can do like 6 divided by 2. Whoops. Put those spaces, make it look nice. And then, so here to kind of just show you that everything's working appropriately. For add, we can see that I got 5. 2 plus 3 does indeed equal 5. If I do subtraction and run it, I get 3. So it's 5 minus 2 is indeed 3. If I do mult, we can see I get 6 because 3 times 2 is 6. And if I do div, or division, we can see that I get back 3.0. And that's that's because usually when you do this division operator, it's going to return some sort of a float because you have that tendency to get decimal values. Python usually handles a lot of what the variable will be in the background, but there is a way to adjust that later, and I will show you how to do that as well later. There's also modulo, and modulo is a little bit weird. You don't typically see this in math. And modulo is usually done with the percent sign, and it returns the remainder of a division. So for example, we can do 12 modulo 5. So what this is really saying is 5 can go into 12 twice with 2 left over. And that 2 left over is what the modulo operator returns. So to kind of prove the point, if I go ahead and print out mod and I run it, you can see that it returns 2. And that's because that's the remainder of this sort of division. So you don't typically see modulo, but it is a very useful operator to have. And so it's worth noting and kind of messing around with if you want to get used to it. But that is also here in Python. So one thing to sort of learn as well, here, I'm going to get rid of these lines here. So we kind of saw earlier about the, if we printed div, when we divided 6 by 2, we ended up getting a float, right? 3.0, 3.0. There is a way to actually force this to be an integer if we want it to be so. And one way of doing that is something known as casting. And casting, all it really is when you want to convert one data type to another. So right now, div returns a float, but maybe I want it to be an integer instead. Well, one way of doing that is to type int and then put inside of it parentheses. And so what this is really doing, or actually, sorry, I'm going to do this here instead, is that the 6 divided by 2 is going to instead be casted as an integer. So when I run it, you can see that now it's 3. So this 6 divided by 2 operator will return the 3.0 that we saw earlier, and int is going to go ahead and cast it and force it to be an integer. Now, one thing to sort of also know with like this type of cast in particular is that it will always kind of round down. So for example, maybe we want to do 5 divided by 2. And 5 divided by 2, as you know, is 2.5. And so when I go ahead and run it, you can see that it returns it as 2. So even though we know normally that 5 divided by 2 is going to be 2.5, when we go ahead and we cast it as an int, it will always round it down to the nearest integer, or round down to the nearest integer. So it's going to go ahead and round it down to 2. So that is the thing to note, is that when you do cast it as an int, it's going to go ahead and is going to end up doing that. And the reason I show casting is for the next thing that we're going to cover, which is concatenation. I alluded to it earlier, and I think it is an important thing to sort of discuss now, is concatenation. So what is concatenation? So concatenation is where you can put 2 strings together. So in this topic of covering concatenation, suppose we wanted to just greet the user every time with any kind of name. So maybe for the sake, I'm going to use my name. And suppose we wanted to say print, we could just say print hello, Noah. And we can do that. But obviously, it doesn't matter what I do here. It's still going to always say hello, Noah, because, well, that's what I typed in here. So how do I get it to be able to take care of this name part that I want it to always acknowledge? So there's something known as concatenation. I'll show you how this kind of works right now. So um, is we use these plus signs. So you write the first part of your string, hello, comma, and then space, plus, and then here's the variable name. And then we would want to put this plus sign right there, yeah. So what this is really doing is saying, start with this first part of the string, hello, comma, space, and then add in whatever this variable name contains, and then add the rest of what comes after. So if I run it, you can see now it says, hello, Dave. I can also say Steve, for example, and it should take it in. And so this concatenation is really just putting these two, or I guess three different strings together and kind of merging them together. And so to kind of bring back to the idea of why the int cast was important is because here in this particular case, if I try running it, we're going to see that we're going to run into an error, which is can only concatenate strings, not ints. So right now it's running into this problem because it's trying to take this string here and this string here, and it's trying to concatenate it with this, but it's not a string, and Python doesn't really know what to do with it. So one way you can do it is that there's a different casting called str, or string, and that's really just concatenating whatever's in between these parentheses to being a string. So if we go ahead and run it, it says hello 8. So it takes in name, which is right now an int, but str will actually turn it into a string. And so this is sort of where casting can kind of be useful as a whole. And I encourage you to kind of mess around with concatenation, maybe make your own kind of ad lib at home and see if that's something that can kind of whet your appetite with working with concatenation and the print statement and working with these different variables and sort of kind of getting an understanding of that. But I think this is quite a lot to kind of cover in a basics video for today. So I think that this is a good place to kind of leave it. If you did enjoy the video, please give it a like and subscribe to the channel if you want to see more videos. I'm trying to release weekly, one video a week. So please stay tuned if you want to see the next installation of this Introduction to Python tutorial series. And yeah.